afternoon, everyone. I am John Suho. People call me John Suho. I am a senior security engineer here at InterSystems, and most of my time is spent doing vulnerability management. But they also let me moonlight by giving presentations on interesting security topics such as this. Today, I'm going to talk to you about two planned security features: the new security database and the security wallet. The motivation behind both of these features is to allow you to do even more to protect access to your system and its secrets. Eventually, they'll also allow for ease of access of sharing those secrets between systems. Our agenda. First, the security database. We'll have a discussion of some currently available security features to remind you of what is. Then we'll discuss the benefits of the new IRISSECURITY database. We'll have a brief demo showing encrypting the new IRISSECURITY database, and then discuss some future IRISSECURITY database features that will make your life even more exciting, in a good way. We may take one or two questions then before moving on to our second topic, the security wallet. We'll discuss the problem of having to use and therefore possibly expose secrets in your code, and then the solution of using the secrets without knowing what they are. We'll have several demos, in the first of which an admin will create and store a symmetric key as a secret, and then a non-admin will use that key without ever seeing it. We'll have another demo in which an admin will be storing a username and password and a key value secret, and then a non-admin will use that username and password against an external web application and will never have to see those credentials. And then another similar demo in which an admin will store an API key and a key value secret, and then another non-admin user will use that API key against an external web application again without ever seeing it. And then we'll talk about some more nifty wallet features down the road. Okay, to frame this, the big overarching question and the reason for all of these features I will simply sum up as: is it secret? Is it safe? All right, this is a database on an InterSystems IRIS instance. It can hold any kind of data your application may need. Some of that data will be sensitive. Could be patient health information, could be personally identifiable information, could be credit card numbers or other financial information, could be the true nature and location of an all-powerful magical ring. The information stored in your application may vary. It would generally be bad if such information were leaked to malicious actors. There are a whole bunch of baddies on the lookout for that info so they can use it for their nefarious purposes. Thankfully, InterSystems IRIS has always offered database encryption. You have always been able to create encryption keys and use them to encrypt your .dat files. And for the sake of completeness, we will also briefly mention that there is journal encryption, data element encryption, as well as transport layer security for network encryption, and much more that you can and should configure in order to secure your system. But for our purposes today, we're just going to focus on database encryption, which, as aforementioned, has always been available in InterSystems IRIS. If you choose to configure database encryption, that means that if those .dat files are ever taken by a malicious actor, they won't be able to decrypt and read them without gaining access to the key. The key file can be stored on disk, where it itself would be password protected, or the key file, for greater security, could be encrypted with a separate KMS key that is stored in the cloud, or the entire encryption key itself could be stored in the cloud and retrieved using the KMIT protocol. This was and is great, but there are limitations here. Specifically, you cannot encrypt the IRISSYS database. That makes sense. You need that database to start up the instance, and you need to start up the instance in order to run the code that can decrypt the other databases. The problem is that there's more in IRISSYS than that. IRISSYS also contains all of the security settings for the instance, including users, roles, web application settings, and much more. And it sure would be nice if we could also make sure that those things were encrypted, but that's not quite how it is at the moment. The solution: move the security settings out of IRISSYS and put them into their own new IRISSECURITY database that can be encrypted. So, how will this work? Well, there's a new database called IRISSECURITY. It is slated to be released with InterSystems IRIS 2024.3. What do you need to do to prepare, all of you nervous admins out there? Probably nothing. All settings will be automatically migrated on upgrade, so that is wonderful. And what can you do once you have the IRISSECURITY database? You can encrypt it. All right, this is exciting. First, a prerequisite. We're not going to show this because it's old stuff that hopefully you're already doing. We'll create a data encryption key. We'll activate it. It'll be the default on the system. What I am going to show you today are some quick demonstrations of changing the encryption startup settings and then restarting to find that your IRISSECURITY database is encrypted. And very quickly, I will just remind you all to, in addition to doing that, encrypt all of your other databases, your journals, your network connections, and so on and so forth. But let's take a look at this demo here. So we've gone into Portal, into the database encryption section. We've already created and configured this encryption key. And we're just going to go to the startup settings, and there'll be this new one called Encrypt IRISSECURITY database. We're just going to flip that to yes. Again, you can do this in the Chewy as well. But once we've done that, we're just going to simulate a restart here. And we're going to go back to our portal, eventually get to our local databases section, where we will find that indeed our IRISSECURITY database is now encrypted. Huzzah, beautiful, lovely. All right, some things you do need to know about the new IRISSECURITY database. It only allows API access. It will not allow for direct global access unless you have %all, but even then, please don't do it. This means that you can't view, copy/merge, or edit the security settings globals directly. If you, long ago, set up some sort of code or task that did directly edit or copy these globals, you'll want to modify that to use the APIs instead. Again, these APIs, these are the normal, existing, long-time APIs like the security package classes, security.users, security.system, etc., the caret security menu, or the management portal. These are there. If you attempt to use any direct global access, you shall not pass. Now, we did have to create a new API for something that only had direct global access. If you're using allow class, allow prefix, allow %, within the web applications, these are settings to allow/disallow certain classes to be run within particular web applications. Before, you could only do this by setting globals. We've created APIs for that so that you can do it here, because again, you should not be touching the security setting globals directly. The IRISSECURITY database does use this new %db IRISSECURITY resource, but that should not matter to you. You don't need to explicitly grant this to any role or user. It will be escalated and granted temporarily within the security API code. So if you are properly using the security APIs instead of direct global access, you won't need to worry about this. All right, now moving on. Moving all the security settings into their own database so you can encrypt that. That will happen later this year. Again, we said that's slated for InterSystems IRIS 2024.3. But after that, in even further along releases, there will be even cooler features. In the future, you'll not only be able to encrypt the security database, you'll be able to mirror it across systems so that different instances will be able to have the same security settings, like the same users, roles, web applications, etc. You'll also be able to set it up as a remote database, so the same security settings can be shared and seen by different ECP members. But One does not simply make this security database available on another system. There is some security information, like a user's last login time, that might need to be written when a user logs in. If the database is read-only, like it would be on a 9 primary mirror member, well, that couldn't happen. So we're carefully planning and sorting out this and other issues, and mirroring and ECP for the IRISSECURITY database will be available at some point after this year, but it is not this day. Oh. All right. Before we move into our part 2, we'll take 1 or 2 questions about the IRISSECURITY database. We've got the product manager in the room. Yes, sir?
So for the upgrade, you said to turn on the security, you have to do an instance restart. Is there a way that we can configure it when we go to 2024.3 to where it automatically encrypts the security database after upgrade, so we don't have to instance restart after upgrade?
Is that something? I'm not certain that would be the case, because you would need to set it up, however briefly, after upgrade. But I will let Andrea speak to that further.
That's accurate what you said, right? So when you upgrade to this instance, the instance will automatically do all the transfer changes, right? And then you cannot do immediately without an upgrade an encryption of the database, right? So you can go in there, do settings, but you can determine at what point you want to do so. You just basically register with the instance the desire to encrypt, and that just hangs there until you do the next restart. And if that restart happens, then it encrypts.
So in theory, you could upgrade, make the class call to update the security database to be encrypted.
And then immediately.
Yeah.
Yes, correct.
Yeah, within.
I didn't know
Yes.
how long it took.
Yes.
Oh, no.
This is straightforward restart. There's no time delay that is significant.
Yeah, it's
Yeah, of course, yes.
It's gonna be a fairly small database, and it'll just happen when you restart. The gentleman in the back.
So, is there going to be an upgrade path that certain steps we have to take? Say, today we fail over, we upgrade our secondary, and then we fail over to this, and then bring the secondary back up so it's connected to the mirror. But then you just fail over the primary. Well, the primary now no longer has the mirroring. Isn't the mirroring going to be messed up since %sys has changed now in the secondary, but it's still the security options are in the primary?
That you can't currently mirror %sys, so that's not something that a case that you could be in.
So how this works is the initial implementation for it, for the security database, is not mirror aware. It is just a new database, and that's it. It's just a new database. So it's local to the instance. It doesn't mirror anything over between the primary and the failover. There's a lot of reasons why that is. We will address those issues. So eventually we will come to this point, and then your question becomes way more interesting, and we will have to figure out what the answer to that one is.
Okay.
Again, it is not this day. We'll take Edouard, and then we'll move on. We'll be time at the end for more.
Very quick question. If you're running container with durable system enabled, if that's when you update to new version,
Yes.
Yes.
Yeah, Edouard's question was, if you are running a container with durable sys enabled, would this just be taken care of on upgrade the same it would with a non-container instance? And the answer is yes. Right. Brand, thank you all. All right. So we've had discussion of one new security feature. What about second new security feature? I don't think they know about second new security feature. All right, let's say you have some code in InterSystems Iris that is going to need to access information that is somehow secured. It could be that the information was previously encrypted, maybe using the existing managed key encryption functionality within InterSystems IRIS using a symmetric key. So in order to decrypt it back to a usable form, your code would need to use that symmetric key. Or it could be that the information is on some external web application, and your code needs to access that info through something like an HTTP request to that application. Hopefully, the admins and developers for the external system care about security, and that application requires authentication, something like some credentials like a username or password or something else. So your code on the InterSystems IRIS instance is going to need to use those credentials in order to log into that other system. So you might need to hard code the necessary secret, whether that's an encryption key or the credentials or whatever else, into your code itself, meaning your secret gets seen by anyone who uses the code. Meaning if anyone, whether a malicious actor or just a fool, took your code, they would be able to see that secret and then use it for themselves. Is there a way to resolve this paradox so that your code, and also the InterSystems IRIS user that your code will run as, can use these secrets without having to know what they are? It's a tricky question. Not quite as tricky as what have I got in my pocket, but the answer to both happens to be a wallet. Our second enhancement to help keep things secret and safe is the security wallet, which, much like a real wallet, is a place where you can keep things you need to use and only bring them out when they need to be used. It will consist of a number of classes that have functionality to create and store secrets, and then separate functionality to use those secrets, sometimes in conjunction with other classes you already know and love. Let's take a look at this first one. %wallet.symmetric-key. This class will interface with $system.encryption algorithms, manage key encryption, and with it, you can use encryption keys with those classes and functions mentioned earlier. Never have to store the encryption keys in your application code. Never have to let the user running that code see them. We also have this %wallet.key value pair. This can be used to store arbitrary key value pairs, like usernames or passwords. This will interface with classes and functions like %net.http request, %soap web clients, SQL gateways, and so forth. And again, you'll be able to use those credentials and values with those classes, never have to store them in your application code, or let the user running them see that code. There is a new resource used in managing the secrets, %admin_wallet. This is the resource needed to allow users to create secrets. Now, when you create a secret, the command you use to create the secret will specify the resource needed to use that secret. So you'll make a secret and you'll say, hey, in order for a user to actually be able to use this secret, they will need this particular resource. All right, let's look at our first demo, in which an admin is going to set up a symmetric key and a secret. Then a different user is going to use that symmetric key to encrypt and then decrypt that data, and they're never going to see the key. All right, so first we have this user here, username Celembrimbor. They're a pretty privileged user. We're going to see that they have %all, and we're going to paste in a command soon in which we're going to create a secret. So again, we're using the %wallet.symmetric-key class. We're using the create method. The name we are giving to our secret is Speak Elvish. That's the name. And then we have this other part in which we define the resource. We say, hey, any user who wants to use this needs the knows Elvish resource. And then because this is a symmetric key secret, it's going to generate a key for us. We, the admin, don't even need to see the key, and we just give it a key length. All right, we're going to run that. We're going to get the status back, and now let's move on to a different user who is going to use that secret. So here, totally separate user, Gandalf, has a different set of roles, right? Access to terminal and this knows Elvish role, which contains the knows Elvish secret that we specified knows Elvish resource that we specified was what we need when we created our secret. And so we're going to paste in this command. We're going to define some plain text, a variable plain text, set friend equal melon. And then we're going to use our class call, %wallet.symmetric_key. And there's a few different functions you can use. We're using AES-CBC managed key encrypt. We're putting in the name of the secret that we defined earlier, speak Elvish, and then we're putting in our plain text variable. And then we're going to define our ciphertext variable with that. When we write out our ciphertext variable, again, there's different functions you could use. Managed key encrypt is going to put a key identifier at the start that's not, again, the key value, but it just means you don't have to look up and store a bunch of other cryptographic stuff. But you see in there, that is definitely not intelligible as the plain text. But then we can use the reverse of that, %wallet.symmetric_key AES-CBC managed key decrypt, and we're going to get the plain text back. And note, again, in all of there, we didn't see what that symmetric key was. All right. Third, this is just so that I can show you that that resource really does work. We're going to have yet another user that's not going to have the same level of privilege. And when they try to run the same commands that our previous user, who did have the required resource in one of their roles is, they're just going to get an access denied. All right, so we get this error here. Again, trying to use this secret, don't have the proper authorization, access denied. And the cool thing about each of those is all of those are audited, right? When we create the secret, when we use the secret, when we fail to use the secret, those are all going to show up in your audit log. All right, we're going to have a second demo here. First, I'm just going to show you that, yeah, there's a web application that you are going to fail to log into if you don't have credentials. Then we're going to create several different credential sets in slightly different ways, and then we're going to attach those credentials to a couple of different HTTP requests in slightly different syntaxes. So first, let me just remind you about HTTP requests. We're going to create an HTTP request. We're going to use an SSL configuration because we care about securing our network connections. We're going to use that HTTPS at the bottom there. Again, you need to both set an SSL configuration and use HTTPS. Not related to the topic today, but just something that I love evangelizing in case you've forgotten. Okay, we're going to read our response. It's going to be a 401 unauthorized because that's what happens when you don't actually have credentials against an application that requires them. And I think I probably passed a 401 unauthorized down at the bottom, but there's one at the top as well. All right, just showing you that you do actually need these. All right, let's go ahead now and look at creating secrets again. Again, this is a different kind of secret. Before we were looking at %wallet.symmetric_key. Now we're looking at %wallet key value. This user doesn't have %all, but they do have a role that grants them %admin wallet. Just trust me that role actually does give you %admin wallet. All right, so we're going to create 3 different key value pair secrets. We're going to be storing username and passwords, but we're not going to call them necessarily username and passwords. So you're going to see it in there. We're going to have one secret called, well, you'll see in a second. Each key is going to be called different. So our first secret up at the top, again, we're using %wallet.keyValue. Create method. The name of our secret is called Strider. We specify a resource. We're going to say, hey, you need the fellowship resource for this. We're going to put in allowed hosts. So you can put in a list of hosts or servers that this is allowed to connect to. So you can't just use it arbitrarily. and then we'll actually define the secret itself. So the first key name is user, and we're going to put in Aragorn. The second key name is password. We're going to put in Son of Arathorn. Now, user and password, those are some special default values, and you'll see in our next slide that if you just call them user and password, then you don't have to specify key names. Those will be the default ones checked and used. The usage here, you can just say, hey, only use this for HTTP, only HTTP requests. If someone tries to use this for SOAP or SQL, not allowed. All right, very similar with our second secret. We're going to give it a name, Greenleaf. We're going to give it the same resource and allow list. But the secret itself, we're not going to use user and password, which were our defaults. We're going to make some custom tags, and you'll see in the next slide, we're going to have syntax to use those custom key names. Again, so this is Legolas, that's the value, and then the key value for my elf password is Son of Thranduil there. And then we have this third secret we're creating. It's going to be called Toss Me. Again, the resource, the allowed hosts are the same, but again, we're going to give it custom specified key names that we're going to reference later. So instead of user and password, we're going to reference Don't Tell the Elf. And all right, so here we're going to show you, yes, that we are yet another user, that this user doesn't in fact have the level of privilege that we said that we needed to use these secrets. It has that resource. Again, the fellowship resource role contains the fellowship resource. You're just going to have to trust me on that. We're going to have 3 HTTP requests, and you'll see, again, the different syntax involved in each of those. That took a little longer than I thought. Sorry. All right. So we're pasting them all in at once, but we'll look at them one at a time. The first HTTP request here, we're using the use secret method we're using the use secret method of the %net.http request class. That's new. And so we put in the name of that secret, Strider, and we put in the format that we want to use the authentication with, which is just basic. And we don't put in any other arguments, and the class knows, oh, we're using basic authentication. I'm going to look for a key named user. I'm going to look for a key named password. I'm going to attach an appropriate HTTP header basic authorization. And so that's what will happen there. And then we're going to go through, and again, we're using HTTPS. Cannot stress that enough. I'm happy to talk about that all day too. And then we got that back. We'll check the status at the end. We make our second HTTP request. We're using use secret again. We put in the name of our second secret. We put in basic authentication, but here we're actually going to specify in this third argument the key name to use for our password. So instead of just saying user, we're saying, no, use the my elf user for our username. And then our fourth argument, we'll put in the name of the key, my elf password, says, please use this key, its value for the password that we're going to use. And it'll, again, attach that to the HTTP request as basic authentication in that proper format. And then for our third one, we're not going to use, we're going to do a slightly different format. So again, we're going to put in the name of the secret, toss me. We're going to, instead of basic, use form. So this will be a form encoded. And then in our next arguments, we're going to put in the form field that we want to use, and then colon, and then the name of the key. So iris username, colon, don't tell. That's the name of the key. Again, not its value. You never have to see its value. And then for our next argument, iris password, that's the form field, and then colon the elf, that's the key name. Again, we never saw the actual key value itself. So are we going to get a 401 with any of these, or are we going to get back what we hoped? Oh, we got back proper return value. So instead of a 401, we have my sword and my bow and my axe. Grand. Very quickly, we'll do another demo, show you the same thing with an XAPI key in a header instead. So we'll create that XAPI key, and then we will go ahead and use it just to show you more of that functionality. This works the same as the same secrets we had before. So we have a user, they have proper levels of, they have %admin _ wallet. Again, just trust me. They will be able to create this secret. This secret is named taters. It requires the potatoes resource, has this list of allowed hosts, and then eventually we will get to the secret itself. I've gotten a little ahead of my demo here, but the secret itself, the key name is potatoes, and then we have the XAPI key, which is ostensibly, possibly, plausibly, a collection of random characters. So we've successfully created that secret, and then let's go ahead and use it with our HTTP request, in which another user, we're back to our Frodo user, but we've given him the additional roles and resources he needs. So he's got the loves potatoes role, which grants him the potatoes resource, which allows him to use this. So we're going to have 2 HTTP requests. Again, the first one, just to show you that we're going to get a 401 if we don't use any credentials, and the second one will actually attach this XAPI key and use that. All right, so our first request, we get this 401. Oh, it's a custom 401. So, that's me evangelizing once again. Use TLS. I will talk about it all day. But yeah, we have this 401 unauthorized, and we get this custom error message, I can't load it for you. And then we run it again, but we use secret. We put in the name of the secret, taters. We specify the format as header, and then we put in the name of the header, API _ key, and then we say which key inside the secret to use to put in that header, our potatoes key. And we went back and did our HTTP request get. And are we going to get a 401, or are we going to get... Oh, we didn't get, I can't load it for you. We got, but I can carry you. So, all right. The wallet is going to come out with the IRISSECURITY database. That, again, is currently slated for InterSystems IRIS 2024.3. The new wallet classes will be stored in the IRISSECURITY database, just like all of the other security settings. Another class that will be included that we couldn't demo here is the %wallet.asymmetric key. This will interface with X509 credential sets, SSL configurations, basically anything that needs a key pair or a key certificate pair. There'll be another function, some more functionality that lets you interface with external secrets managers, so you'll be able to reach out to some sort of third party like Vault and store your secrets in there. But again, this will be implemented further down the road and not available in the initial release. Once more, it is not this day. One thing that I was saving just for the end here, eventually the %wallet.keyValue feature will support functionality with interoperability components. So your integrators will be able to use credentials and never have to see them. All right, recap, there and back again. We discussed the security database. The new IRISSECURITY database will migrate security settings into that database so it can be separate, so that it can be encrypted and eventually shared via mirroring in ECP. We have a new security wallet which will allow admins to configure secrets that applications and users can use without ever having to know the secrets themselves. If you have questions, here's my contact information, but a much better resource would be Andreas Dico, one of the principal product managers here at InterSystems, because I am no manager of products. Thank you for joining us today. We know your secrets are precious. I'm not just trolling you when I tell you that better security isn't a pipe dream. And all of this is because we here at InterSystems want you to be able to secure your systems in a way that will make attackers more likely to say, all right then, keep your secrets. If we have any more questions. The question is whether database encryption keys can be stored within a secret. You can store managed key. Do I have your question correct? You can store managed key encryption within there, but for an entire database, no, that would not be stored within a secret. I have that correct? More questions? Rich?
For the demonstration, you're doing a lot of command line API calls. Is there ever your intention to have a user, an SMP interface for doing this?
Answer from product or development? Unknown, presently not a plan. Question was, what book were all of those references from? They're from a movie. All right, thank you all. Have a great day.